So this is on page 36 of your unit handout. We're going to be using a formula. And this formula is intimidating until you realize you already know how to use the formula. That's what we've just been doing. Okay? I am going to review everything that I've talked about here, but I'm going to add more details to it. Okay? So yesterday we developed rules that could be used to expand binomials of the form x plus y to the n. And x doesn't have to be x, it could be 2x, it could be 3b, whatever. It doesn't even have to be plus, it could be minus, and it could be minus 5y or minus x squared. It could be anything. So, you've seen this already, but there's more to the story. Okay? If you want to expand x plus y to the 5, you reason out that there are 6 terms, because there's always one more term than n. So you could look at the 6th row of Pascal's triangle and go from there. And this is what we've done. I've already shown this to you. So I'm going to flip through it rather quickly. And using just the patterns, this has nothing to do with skipping terms or choices or anything like that. You say x carries all of the exponents, y carries none of them. X carries one less, y carries one more, and on and on and on. But the very final example yesterday illustrated the fact that that 1 is 5 choose 0, that 5 is 5 choose 1. The numbers in Pascal's triangle, in the 6th row of Pascal's triangle, are 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Thereby eliminating the need to look at Pascal's triangle. If it's x plus y to the 12, I don't have to build Pascal's triangle down to the 13th row. It's going to get monstrous. I can just say the first number will be 12 choose 0, then 12 choose 1, etc. I already showed this to you when we reviewed at the beginning of class before we went over the problems that you had. But what that is that formula. And the most difficult thing about that formula is understanding the k plus 1 on the left. So let's just leave that alone for a second. Would you agree that this key number I've been talking about is the number that goes here? That is to say, the first term you use 0 there, the second term you use 1, the third term you choose 2. Are you with me on this? Okay. And would you agree that what I've kind of trained you into understanding is that that key number matches the number on y? And each term has its own unique key number. Okay. But would you agree all of the terms use the same n? If this is x plus y to the 7, we would have a 7 right here. Well, let's imagine we had a 7 here, and the key number was 3. What number would x have? Well, it has to be a number that when added to 3 gives you 7, which is 4. Are you with me on that? Well, 4 is 7 minus 3. That's all the n minus k means. It means load an exponent in there that has the right value to add to give the total. Now, the toughest part about this equation is this k plus 1. But let me ask you a question here. What is the key number for, say, the 6th term in the expansion? Who can tell me what the key number for the 6th term of an expansion is? Darius, you know? Excellent. It's 5. It's 1 less, right? That's just, we have to remember that. So k is 5. Well, look what happens if you put 5 right here. You get t sub 5 plus 1. Five plus 1 is 6. It's k plus 1 because it's telling you you need to put a number in for k that when you add 1 to it gives you the term number. And I find over the years that I tell students more and more, don't even worry about this k plus 1. You can just go T6 here and know that k is 5. I think the k plus 1 is confusing. It adds a layer of confusion that's not necessary. So we call that the general term of the binomial expansion, and it's used to find any term in any expansion of a binomial where it's raised to a natural exponent. Each term has a unique value of k, and the value of k is always one less than the term number. And I feel as though I've mentioned this so many times already that I don't need to go into more detail. What is the fifth term of this expansion? Now, what I'm going to do is create the fifth term of the expansion as if we didn't know about the formula, as if it were before this lesson, with what we learned yesterday. I'm going to say that the fifth term of the expansion will be, well, let's see, n is 7. My x is 2x. My y is negative 3y. And this would be what I would use for the fifth term or the sixth term or the seventh term or the second term. But for T5, I need to use k equals 4 for for the key number for the fifth term. And I admit that I'm trying to do this without talking about the formula, but I've also introduced you to the fact that I call the key number k, right? Well, from yesterday, we've learned that it's always going to be a term of the form n choose the key number, and n is 7, my mistake. N choose the key number, which is 4, multiplied by x, and here's my thinking again, I can't help it. I don't load that exponent in. I load the exponent on y in, leaving a bit of room for that exponent on x, as the key number, and then I say, what exponent do I put on x? Well, it's 4 taken away from 7, which will give me 3. Right? It has to be 3 because 3 plus 4 is 7. Are you with me on the construction of that term? Okay, so this was the point that I tried to sell in the video yesterday on the last example. I didn't have to find the first, second, third, and fourth terms to get here. And now I work this out. I'm not going to write nearly as much in terms of the coefficients as I did before. I'm simply going to do that. I'll write one more thing. I will. The coefficients will be 7. The coefficient will be 7, choose 4, multiplied by 2 cubed. I noticed yesterday on the video that when I wrote something like 2 cubed, sometimes I put the cubed inside of the brackets. And that's fair game, but if the base is negative, it needs to be outside. So I should maybe make a habit of always putting it outside. Negative 3 to the 4, and then I'm going to have x cubed y to the 4. So do me a favor and calculate what that's going to work out to for the coefficient. I'll do the same up here. I get 22,680. Okay. So the fifth term is 22,680. X cubed, y to the 4. I'm just racking my brain right now. I don't think you would ever see a question on an exam that asked you to expand a whole binomial to a power or to an exponent. I think it's more about finding specific terms or about the examples that we're going to look at today in general. Any questions with number 1? All right. What's the sixth term in this expansion? So n is equal to 9. x is equal to 3x. We're now looking at a term, we are now looking at finding a term and completing an example like the one Lynette asked about, where our x's contain x's and our y's also contain x's. My y is negative 1 over x squared. The brackets around the 3x are not necessary, but for completeness, let's put them. And the key number in this question is 5. Can somebody explain why I set apart that k from my list of items on the left? There's a reason that I don't want to put my k in this list on the left. And it may seem trivial to you, but it's because the list on the left is true for every term. K equals 5 is only true in this question for finding the sixth term. And by the way, you see how I'm getting 5? 1 less than the term number. All we have to do is put everything in. T6, k plus 1, if you want to put the k plus 1, you can, is 9 choose 5, 3x raised to the 9 minus 5. You can get in the habit of subtracting these exponents to put the result up there. You don't have to do it the way I normally do. And this is to the 5. So my sixth term will contain a coefficient with a factor of 9 choose 5, a factor of 3 to the 4, and a factor of negative 1 to the 5, making my coefficient negative because the negative is raised to an odd exponent. It's going to contain an x to the 4. It's going to contain an x to the 4. And it's going to contain an over x squared. That's just how I say it. It's going to contain a 1 over x squared raised to the 5. So you have two tasks now. You have to figure out what this coefficient is, and you have to figure out what the variable component of the term is. We have a power of a power here. I don't think we need to write it in our work, but 1 over x squared to the 5 is 1 over x to the 10. So we have x to the 4 over x to the 10, which is over x to the 6. And this, I couldn't even begin. I couldn't even estimate it. 9 choose 5 multiplied by 81. I know that 3 to the 4 is 81. Negative 1 to the 5 is negative 1. But if you like, for completeness sake, that's how you would enter it. Negative 10,206. Anybody else get that? Okay. And this would probably be written as negative 10,206 over x to the 6. Any questions with example 2? There's so many moving parts to these things that you just have to be careful. Thoughtful and organized. Now comes the type of problem that they start to get more difficult. If you expand this out, one of the terms will contain b cubed. And it isn't going to be easy to find out which term that is, because it's not that it's b to the n minus 1. It doesn't work that way because x is actually b squared and y contains b's as well. So each term has b's in it raised to an exponent that's an amalgam of both terms in the binomial. So what your goal here is, this is, over the years I've figured that this is maybe the easiest approach. There are more algebraic approaches and some of you might be interested in them, but I'm not going to do it right now. Your goal is, what's the key? I won't even start there. Your goal is, what term do we want? I mean, I know we want the term that's going to have b cubed, but I'm asking, is that the first term or the second term or the third term or the fourth term, etc.? And the reason why that's important is if we know the answer to that question, we will be able to figure out the key number. Because if I discover that it's the fifth term, the key number is 4. So what we're going to actually do is take a step backwards and expand this out using the traditional approach, starting at term 1 and continuing on down the line. You have more room on paper. I'm just going to move down so that I have enough room. It's b squared minus 3 over b to the 9. Let me rewrite it here. B squared minus 3 over b to the 9. And I'm going to make a note here that n is 9, x is b squared, and y is negative 3 over b. Looks like a 5. There we go. Does that summarize the binomial expansion before it's expanded properly? That look okay? Okay. So my first term will be 9, choose 0. It will contain a b squared raised to the 9, and it will contain a negative 3b over b, rather, raised to the 0. Okay? My only question right now to you is this. Will that have b cubed when it's simplified? No. It's going to contain b to the 18. We know now that it's not, the term we're after is not the first term. Now, be patient. We're not going to go all the way until we find the term. The next term would be 9, choose 1. It would contain b squared to the 8. So I'm not even thinking of a key number here. I'm just using the pattern. And it will contain negative 3 over b to the 1. My question is, will this contain b cubed when it's simplified? Well, when we simplify b squared to the 8 times 1 over b, I'm only looking at the variables to the 1, we get b to the 16 over b to the 1 will contain b to the 15. This is not the term we're after. Before I do one more term, how many of you understand, is there a question with this? How many of you understand why the exponent dropped by 3? Why is that, Will?
Because the term over b is growing by 1, and the b squared is dropping by 1. So.
Right. Perfect. Sorry to interrupt. We're losing a b squared each time, so we're losing 2 b's. But we're gaining an over b, which means we're losing another b. And, you know, we can demonstrate that that's going to work, I guess. This should contain b to the 12. We'll just check it out. It's going to be 9, choose 2, b squared to the 7, negative 3 over b squared. Well, b squared to the 7 is b to the 14. And we have over b squared. B to the 14 over b squared is b to the 12. And now we've established a pattern. And you want to be careful here because on a written response, you would establish the pattern this way. If you can just look at it and know that the exponent is going to start off at 18 and drop by 3 each time, that requires a level of explanation that you have to put on paper. But see, now what I have is this. I can construct from this a table, and I can say, I can basically do some finger counting in a formal manner on a table until I get to b cubed, and then I know the term number. And all of that is done simply to find the term number. So I'm going to keep going. If we're talking about term 5, it's b to the 6. Term 6 is b cubed. Jackpot. That's what we're after, which means it's the 6th term. And that means if it's T6, we have the key number, and this question is now a question like the previous examples. You know what n is, you know what x is, you know what y is. Forgot my equal sign there. You know what y is, and now you can use the key number of 5 to answer the question. So T6 will be 9, n is 9, right? 9, choose 5. It will contain my x, which was actually b squared, to the 9 minus 5, which is 4, and it will contain my negative 3 over b, which is my y, to the 5, and now we simplify it. So you're going to have to take 9, choose 5 times negative 3 to the 5 to get a coefficient. And if you have faith in your work, and you have faith in the algebra, this will be b cubed, but you can certainly work it out, because b squared to the 4 is b to the 8. And then we have to divide by b to the 5, so you get b cubed. Are you getting negative 30,618? Okay, that's it. So when I do the next example, I'm going to abbreviate some of my work in my instruction, because I've shown you what you need to show if this is a written response question. If this is a written response question, you kind of need to show all of this. You need justification as to why k equals 5. If you can figure out that k equals 5 in your head, great. You can count things on fingers, but you need to show that work. What is the constant term in this expansion? Well, a constant term means it's going to contain x to the 0. A constant term means there's no x's. And that means that this x squared which is our x, and this negative 1 over x, which is our y, are going to work together to cancel each other out entirely. N, of course, is 6. We're after which term? Because then we can determine k. So what I am about to write and talk about is not nearly as much as you need on a written response, okay? What will my first term contain? I didn't put equals. What will my first term contain for x's? Well, it's going to contain x squared to the 6. It's going to contain x to the 12. What will my second term contain? Well, I'm just going to kind of do this on scrap paper. It's going to contain x squared to the 5, and it's going to contain 1 over x to the 1. This is wrong. I'm not saying this is the term. I'm saying these are the x's in the term. There's still a negative 1 there that I'm not including. When I simplify this, it's x to the 9. Are you with me? It's going to be dropping by 3 each time. Once you see that it goes from 12 to 9, you would want to demonstrate it on a written response, but it goes from 12 to 9, so it's dropping by 3. So if it drops by 3 again, and again, and again, we will get to x to the 0. It is the 5th term, which means we're looking at, thank you, Lynette, a key number of 4. And now we can answer the question. The key number is 4. So it will be for the fifth term, it will be n, which is 6. Choose the key number. It will contain x squared raised to the 2, 6 minus 4. It will contain negative 1 over x raised to the 4. If you have confidence in your abilities here, you should understand that the negative 1 to the 4 is just 1. You should understand that all of the x's are going to cancel without even thinking about it because they have to. But when you do think about it and look at it, they do cancel. So you're left with 6, choose 4. And I don't know, is it 35? I'm probably totally out to lunch there. 21? 15. So the fifth term is 15. As I said, there are algebraic ways to do these questions, and we don't have time for me to show them to you, but tomorrow I will. We have one last example. This time, we know a term, but we're missing part of the binomial. And I know that this is a little cruel, but you've seen this many times. Obviously, this is not the key number, right? That k is not the k in our formula. It's just some constant. And we're told that if you expand this out, you get a term that's equal to this, to 4000x cubed. So what number does k have to be in this binomial so that when you do expand it out, you get this? Well, our first role or job is which term? Which term is this? Is this the 12th term? Is it the 5th term? Well, it can't be the 12th because n is only 8. And we're going to find out which term it is in the exact same way we did in the previous two examples. But I'm going to do this an even quicker way, and the reason why is this is kx minus 6, so we don't really need to think too much about this. The first term will contain x to the 8. It's not even x squared to the 8, it's x to the 8. The second term will contain x to the 7. Let me see if I can get my numbers counted correctly this time. We're going to go down until we get to x to the 3, because the term we know is x to the 3. So x to the 6, x to the 5, x to the 4, x to the 3. I better check my counting. 8, 7, 6, 5, 4, 3. T2, T3, T4, T5, T6. If you were to expand this out, regardless of what number that k is, the sixth term would be something that contains x to the 3. Well, that means this is the sixth term. Our approach here is just a little bit different. Our sixth term is going to be, I got to look back at my n, 8, choose 5. Sixth term is k equals 5, is a key number of 5. It's going to contain my x, which is kx, raised to the difference between 8 and 5. And it's going to contain my y, which is negative 6 raised to the 5. Let's simplify this. You'll want to grab your calculator because I want you to figure out what the coefficient is going to be, and the coefficient is going to be monstrous. 8 choose 5 times negative 6 to the 5. Well, monstrous is a relative word, but negative 6 to the 5, even that is a pretty big number. I'm getting negative 435,456. I'm seeing a couple of nods. So the sixth term is negative 435,436. 456. It will contain a k cubed, and it will contain an x cubed. So how am I going to find k? Miles?
You said it equal to what you're looking. Because it will equal this number, right?
Yeah, it will equal what you're told the term is. T6, you're told what it is. It's negative 224,000 x cubed. In other words, I'm going to do that in a second, but I just want to point out to you that this has to be negative 224,000 to get negative 224,000 x cubed. How algebraically does that work? Well, algebraically, we say that that term equals negative 435,456 k cubed x cubed, and we divide both sides by x cubed. We're dividing by x's, which I've told you in the past you shouldn't be doing, but we're not solving for x. So it's not like we're eliminating or creating non-permissible values or anything. I can now take 224,000 and divide by 435,456. As a fraction, it's that. I've got to change this question for next time. There's nothing wrong with it. I just don't like the numbers that come out. We get 125 over 243 for k cubed. The cube root of 125 is 5. I don't think 243 is a perfect cube. I thought it should be, but I don't think so. 9 would be 729 or something. I don't think it is. So the best we can put here is that k has a value of 5 over cube root of 243. The cube root of 125 is 5. I don't think it's worth our time to simplify the cube root of 243. We could, because I think 27 divides into it, and 27 is a perfect cube. So that's the value of k. These last couple of problems, well, the examples in this lesson really are the examples that you need to know how to do for sure. We have a little bit less than 10 minutes left, and we would normally have a bit more time, but we have to go over the combinations and that other stuff as well. So.